Hello everyone, and welcome back to the channel History of the Ancient World. Today, we're journeying back in time to explore one of the greatest engineering marvels of antiquity, the Roman aqueducts. These incredible structures weren't just pipes to carry water. They were the very lifelines of the Roman Empire, a symbol of its power, ingenuity, and its commitment to public welfare. Imagine a city like Rome, bustling with over 1 million people. How do you provide enough fresh water for drinking, for the grand public baths, the ornamental fountains, and even for flushing away waste? The answer lay in a network of channels, tunnels, and bridges that stretched for miles across the landscape, a testament to an ambition that literally reshaped the world. So grab a cup of water, get comfortable, and let's dive into the story of how the Romans conquered the challenge of thirst and hygiene on an unprecedented scale. The story of the Roman aqueducts begins not with grand arches, but underground. The very first one, the Aqua Appia, was built in 312 BC by the censor Appius Claudius Caecus, the same man famous for the Appian Way. Unlike the iconic aqueducts we often picture, this first one was almost entirely subterranean, a practical choice to protect it from enemies during the Samnite Wars. It ran for about 10 miles, a modest start, but it set a revolutionary precedent. For the first time, a major city had a consistent, gravity-fed supply of fresh water brought from a distant source. This was a game changer. It meant cleaner drinking water, better public health, and a tangible improvement in the quality of daily life for the average Roman citizen. This initial success sparked an engineering revolution that would last for centuries. As Rome grew in size and confidence, so did the scale of its aqueduct projects. The engineers, or architecti as they were known, became masters of hydrology and civil engineering. Their primary tool was gravity. The entire system, from the water source in the hills to its final destination in the city, relied on a subtle, continuous downward slope. The precision required was astounding. The ideal gradient was just a few inches of drop for every 100 feet of length. Too steep, and the rushing water would erode the channel. Too shallow, and the flow would stagnate. To achieve this, Roman surveyors used simple but effective tools like the chorobates, a long wooden level, and the groma for laying out right angles. They would meticulously map the terrain, choosing a path that navigated hills and valleys with the most efficient gradient possible. When the terrain became too difficult, Roman engineers didn't back down. They innovated. If a hill stood in the way, they would tunnel straight through it, sometimes for miles. These tunnels were dug by hand, a dark, laborious task lit only by oil lamps. When a valley or river needed to be crossed, they built the magnificent arched bridges that have become so iconic. The Pont du Gard in southern France is a breathtaking example, standing nearly 160 feet tall. It's not just a bridge for water, it's a masterpiece of architecture, a statement of Roman dominance over nature itself. These arches were not just for show, they were structurally brilliant, allowing for great height and stability while using less material than a solid wall. The construction was a massive undertaking, involving legions of soldiers, skilled masons, and countless laborers. But what happened when a valley was too deep or wide even for a bridge? The Romans had another clever solution, the inverted siphon. Instead of building a massive bridge, they would run the water down one side of the valley in sealed lead or ceramic pipes. The pressure built up at the bottom would then force the water up the other side, almost to the original height. This principle, which we learn in basic physics today, was expertly applied by Roman engineers over 2,000 years ago. It required strong, well-sealed pipes to handle the immense pressure, a testament to their advanced metallurgy and manufacturing skills. This flexibility allowed them to conquer almost any geographical obstacle, ensuring the water's journey to Rome was uninterrupted. Once the water reached the city, it didn't just pour out into the streets. It was channeled into a complex and highly organized distribution system. The main aqueduct line would terminate at a large distribution tank called a castellum aquae. From this central hub, the water was diverted into a network of smaller channels and lead pipes known as fistulae. These pipes fed the three main priorities of the city. First and foremost were the public fountains, which provided free, accessible drinking water for the populace. This was a fundamental public service. Next came the public baths, or thermae, which were central to Roman social life. Finally, any surplus water was sold to wealthy private citizens who could afford to have it piped directly into their luxurious villas. This system was carefully managed with officials called curatores aquarum, overseeing maintenance and preventing illegal tapping of the water lines. The impact of the aqueducts on Roman life cannot be overstated. They were the engine of Roman urbanization. They allowed cities to grow to unprecedented sizes, supporting massive populations in a relatively healthy environment. The constant supply of fresh water dramatically improved public sanitation, flushing waste through elaborate sewer systems, like the Cloaca Maxima in Rome. This reduced the spread of waterborne diseases that plagued many other ancient cities. The aqueducts also fueled a culture of leisure and luxury. The grand imperial baths were not just for getting clean. They were social centers with libraries, gyms, and gardens, all made possible by the abundant flow of water. The beautiful fountains that decorated the city squares were a constant, visible reminder of the state's power and its provision for the people. Over a period of 500 years, Rome built 11 major aqueducts, with a combined length of over 350 miles. Together, they supplied the city with an amount of water per person that rivals many modern cities today. And this wasn't just happening in Rome. Across the empire, from Spain to North Africa to the Middle East, Roman engineers constructed aqueducts to serve provincial cities, bringing the Roman standard of living to the far reaches of their territory. Many of these structures were so well built that they continued to function for centuries after the fall of the Western Roman Empire. In fact, some sections, like the Aqua Vergo in Rome, which feeds the Trevi fountain, are still in use today, a living link to the ancient world. The legacy of the Roman aqueducts is a powerful lesson in the importance of public infrastructure. They demonstrate how long-term investment in engineering can fundamentally transform a society, promoting health, enabling growth, and creating a shared civic identity. When we look at the ruins of these majestic structures, we see more than just old stones. We see the ambition, the skill, and the foresight of a civilization that understood the fundamental importance of water. They are a timeless reminder that great societies are built not just on military might, but on the ability to provide for the well-being of their citizens. Thank you so much for joining us on this deep dive into the world of Roman aqueducts. It's truly amazing to think about the ingenuity and hard work that went into creating these wonders of the ancient world. What part of Roman engineering fascinates you the most? Let us know down in the comments. We love reading your thoughts and ideas for future videos. If you enjoyed this journey back in time, please give this video a thumbs up and consider subscribing to History of the Ancient World for more stories from our shared past. Don't forget to hit that notification bell so you won't miss our next adventure. Thanks again for watching, and we'll see you in the next one.